So, hello everyone, this is Zahid Bashir. Today we are going to discuss Smart PLS4 in much deeper detail in our training session, Quantitative Primary Data Analysis. And let's start it in our usual way. I am Zahid Bashir, your trainer. I am a faculty member in the Department of Commerce, University of Gujarat, and I am also a PhD scholar in Delhi College of Commerce, University of Punjab. So I am going to provide this wonderful and this learning experience for you people who have a basic awareness or who have no awareness about the Smart PLS4. So we have came to Smart PLS4. Today is the training day 12th, and we have covered SPSS in first 11 training days, and we have covered some basic aspects of Smart PLS like its download and its installation, and how we can start Smart PLS, and we can perform some basic functions like PLS algorithm. So we will discuss in much deeper detail today regarding the different aspects of Smart PLS. So today is 20th January 2024. Our session will start from 6:30 and it will end up in 9:30, and it will be divided in three sessions actually. So let's start from today's topic. Session one includes 6 to 7:30 p.m. Regarding the basics plus CFA-SEM first order only. Then we will cover CFA PLS-SEM second order, higher order. Then we will cover the Hayes process and MGA, which is multi-group analysis, in our third session. So today we will cover these topics in much deeper and much speedy detail. So buckle up your sittings, and you would be able to learn a lot of things regarding Smart PLS4. So first of all, you need to understand, if you are new to structural equation modeling, you need to understand what is SEM, because in structural equation modeling or Smart PLS, SEM is involved. So what is SEM? SEM is basically structural equation modeling, and it is a statistical method used in social sciences and other field to test and estimate relationship between variables. Um, some of the people may confuse the SEM with regression, but there is a difference between SEM and regression. And I will let you know what are the differences between SEM and regression. So it is a versatile and comprehensive approach that combines aspects of factor analysis and multiple regression analysis. In my yesterday session, I have given the session about EFA, which is exploratory factor analysis, in which I have discussed the detail how you can reduce your factors on the basis of EFA. So basically, the SEM is basically the combination of factor analysis and multiple regression analysis. So SEM allows researcher to examine complex relationship among observed and latent variable. I will let you know what does these both concept mean, but what does it mean by observed variables and what does mean by latent or unobserved variable, by specifying and testing a set of interrelated hypotheses. So you may need to understand some basic components of SEM. It includes the path diagram. SEM is often presented using path diagram, which visually illustrate the relationship between variable through arrows like path and shapes representing observed and latent variable. So it will be the basic component of SEM, and you need to understand what do you mean by path. So in some next slides, I will let you know how we indicate a path. So it means an arrow. An arrow basically indicates a path towards a shape. So what do we mean by observed and latent variable? In SEM, variable can be either observed, it means measured directly, or latent, it means they are measured indirectly. So if a variable is measured indirectly from other indicators, other factors, it may be considered as a latent variable. But if if a variable is measured directly, we can say it as a observed variable. I will explain this concept in much deeper detail in the coming slides. So latent variable help capture underlying construct that may not be directly measurable. So what do you mean by structural model and measurement model? SEM is divided into two main components. One is structural model, which represent the relationship among latent variable, and the second one is the measurement model, which represent how observed variables relate to their corresponding latent variable. So when we are dealing with the relationship between observed and unobserved variable, we are basically referring towards measurement model. But when we are dealing with the relationship of latent variables, we may be referred towards structural model. So you need to understand the difference, but I will let you know in much deeper detail in coming slides. This is just a short review of the basic components of SAM. So what is the difference between traditional regression and SEM? Because at the start of my discussion, I let you know that SEM is different from regression. But what are the differences? How can we understand that our data requires the regression analysis or our data requires the SEM? So, in order to decide whether we need to use the SEM analysis or we need to use the regression analysis, we should know the differences between both techniques. So, structural equation modeling and traditional regression analysis have some similarities, as both are statistical technique used to examine the relationship between variable. However, they differ in several key aspects. Here are some of the main differences between SEM and traditional regression analysis. So, what are these differences? How can we differentiate whether we need to use the regression or we need to use the SEM analysis? So, there are a number of ways, or there are a number of, you can say, consideration that we need to consider. The first one is the complexity of model. In case of traditional regression, typically models relationship between a dependent variable and one or more independent variable. So when we have dependent and independent variable and we need to analyze the relationship between them, we simply assume that traditional regression analysis is much suitable for us. It assumes a simple linear relationship between variable, whereas in case of SEM, it allows for the modeling of complex relationship. So what does we mean by complex relationship? It means when we are considering observed and latent variable rather than dependent and independent, or in addition to dependent and independent, we are considering the latent variable. If you do not have an idea about latent variable, in the upcoming slides, I will let you know in much deeper detail what we mean by latent variable. So in case of SEM, we are much concerned about observed and latent variable in addition to dependent and independent. SEM can incorporate all multiple dependent and independent variables simultaneously, as well as account for direct and indirect effect. In case of regression, you may be considering one dependent variable at a time. You may be regressing a number of independent variable against one dependent variable at a time. But in case of SEM, you may consider multiple independent variable with multiple dependent variable at a time, so relationship becomes complex in case of SEM. So if the purpose of your study is to consider a number of complex relationship, it means you may have more than one dependent variable in your study, or you may be considering the relationship up to the level of observed and latent variable, and you are designing a model which is much complex and it cannot be possible using the traditional regression model, then you are going to use the SEM model, which deals with the complex relationship. So I think you have understand this concept. The next thing that you need to understand
Sir, I have a
regarding,
question.
yes.
Sir, if we have multiple independent variables, I mean 7 to 8 independent variables and just one dependent variable, should we do simple linear, multiple regression, or I'm sorry, or we should go for the SEM?
Basically, preferably we should go for traditional regression. But if we are dealing uh, a relationship with, you can say, a latent variable, a complex relationship, like we want to consider mediation, moderation, serial mediation, and something like this. In case of single dependent variable and a lot of independent variable, then we need to consider the SEM model, because in case of SEM model we can deal with complex relationship. And what do we mean by complex relationship? The relation in diagrammic shape becomes a complex one that we cannot easily deal with the regression. Somehow we can also use the SEM as a alternative to the regression model also. But in some cases where the model is very complex and we cannot easily deal with the regression, then we should use the SEM analysis. Are you okay with the answer? Can we proceed further? All right. Well, the next thing is basically the inclusion of latent variable. When we are considering with traditional regression, our focus may be on observed variable. Basically, observed variable is a variable which it directly observed by its, you can say, measurements. In case of regression analysis, you must have the observed variable. You cannot use latent variable in case of traditional regression. Focus on observed variable only. It assumes that all variable are directly measurable and there is no consideration for unobserved construct. This is the basic consideration, the point you were asking in your question. If we have a dependent variable and we have a lot of independent variable, should we use the SEM analysis, or should we go towards the regression analysis? So if there are unobserved constructs or unobserved variable, whether it is dependent or whether it is independent, if they are not measured, and you need to measure them indirectly, then you need to go towards the SEM. But if they are already measured, if you have the values, if you have the measurements of your dependent and independent variable and you have already measured them, you need to go to traditional regression analysis. So SEM introduces latent variable which are unobserved constructs that represent underlying concepts. Latent variable help capture the true nature of constructs then that may not be directly measurable, reducing measurement error. So the third consideration is measurement error. In case of traditional regression, it assumes that observed variable are measured without error. So whenever we have dependent variable, we may have independent variable which is already measured. So it is assumed that they are measured without error, which may not reflect the reality of data collection. Um in case of SEM, it recognizes and accounts for measurement error. It may also indicate that your latent constructs or your unobserved variable may have some error. It will indicate when we analyze the data using the SEM. But in case of regression analysis, we may now not have the measurement error. So latent variable in SEM represent the true underlying constructs, separating them from the measurement of these constructs by observed variable. Then we may have the formation of equation in simultaneous equation form. The traditional regression typically estimates parameter in separate equations, and the relationship are assumed to be independent. While in case of SEM, estimate parameters simultaneously in a system of equation. So as I have previously told you that you may have more than one dependent variable in addition to more than one independent variable. So you can simultaneously estimate your equations. But in case of regression, you need to estimate your each dependent variable with each separate equation. So in case of SEM, you can do it simultaneously if you have more than one dependent variable. But in case of traditional equation, you need to consider each dependent variable as a each separate equation. So this is especially useful when examining complex model with interrelated variables. So model fit indices, in case of traditional regression, it lacks standardized measure of model fit. You may need you may have only the R square. You may need to have the F square, F value. You may have the model fitness value, but there are a lot of model fit indices which you cannot indicate in traditional regression. So in case of SEM, you may have the detailed model fit indices like chi-square, like comparative fit indexes, like CFI